Hi, everyone. I'm away at a meeting at the Brockville board office today. So I made this video for you to continue on from yesterday's stuff. So we looked yesterday at the connection between angle and slope, and we investigated and found that there's a button on the calculator. It has to do with the relationship between the angle in a right triangle and the slope. And so we found it was the tan button. And so today we're going to extend to the official tan or tangent ratio lesson. Instead of thinking of it as just as slope and rise over run, we're going to extend to the official more the names that are linked with the angles themselves rather than it being rise and run and slope. Because there's more to it than that, right? There's more ratios than just rise over run. And so we need to have all of the possible ratios of sides that we will have to work with. So just as a quick review from yesterday, we found that the tan button of the angle, so tangent ratio of the angle, equals rise over run. And so in each example that we did yesterday, the only thing that changed was the value that was missing. So sometimes we'd be missing this one, sometimes we'd be missing, in which case you'd be given all those, or maybe you were missing this one, in which case you were given this and this. And if I remember right, I think we even did the other one here where if I was missing this one, I have to be given both of those. Basically, any equation where you're missing one thing, you can solve for it, the missing piece, right? So it's just algebra at that point. So this was what we saw. We saw the right, we had a right triangle, but we were thinking of it more as like a slope on a graph. We have rise and run. And so the slope equals the rise over run, which also equals this tangent ratio button of that angle. And literally the button just gives you what the ratio of this side as a number over this side as a number. When we measured it, we found that value was this, right? This gave us number over number. It gave us the slope. So it's just I do that lesson just to try and demystify these magical buttons. There's more than one, obviously. The tan button, we saw what it really does, right? What it means. So yeah, 20 lessons show the connection between the button and the ratio of the sides and so on. And so, when we're doing these, oh, by the way, this video here, feel free to speed me up or slow me down with the gear setting on YouTube, or press pause and try questions and so on, of course, right? So someone can help out with that, whoever's leading the class here. So if we were doing those as an opening question, we would have noticed these sides as rise and run. And then we're going to come back and do these the official way as well by the end of this lesson. So in this one here, it'd be pretty easy where we'd say, okay, well, I know the tan ratio of 38 equals the slope, and the slope equals the y over the 12, right? We're thinking of it literally as rise over run. And, this equals the slope. And so it all makes sense. And we have this missing piece of the y. And so we would do tan of 38. So we would do tan of 38. So hopefully we're in degrees here, 38. And then I think do tan of it with this calculator. Some calculators you'd do tan and then the 38 and then hit enter. So tan of 38, I don't know what that little 0 is there, but it should be 0.78. I'll know when I look in the next slide here. I have the previous answers from a calculator that I know better, used more. So we have that, and then at that point it's just algebra to solve. So we multiply both sides by 12 and end up with an answer of, just multiply that by 12. Right, so 9.4 or so. If we're rounding to one decimal place. 9.4. Let's just do a quick check on my numbers here to see if that was, so I rounded to 9.38 last time. Okay, so the tan button on the calculator is working the way it's supposed to. And then this one here, if I look at this one, I'd be like, well, I know this is rise over run again here. And again, we'll come back and do the official version as well. I just have included this lesson for a while now because it helps people see what the buttons are really doing, rather than just being a big old memorization activity or whatever. Anyways, X on both sides, multiplying, and then if you want, we could do the divide, but usually people get messed up at that point. So I'm just going to do that, and we're going to divide out the tan 80. And once in a while, the smartboard is going off on me here. That's why the lines are off there. So X equals the 10 divided by the tan 80. And we could have done tan 80 as a number earlier on as well, but this works too. So again, we want 10 divided by tan 80. So 10 divided by 80 tan. I don't know if that's, yeah, it looks like it's doing the right thing there. And then equals, yeah, so 1.76. I wasn't sure. Oh, this section of the smartboard is off for some reason. What was it? 1.76. I'll write it over there. Just move it in for now until I align the smartboard. So the 1.76 number is there. And if you're not sure if the calculator is doing the right stuff, you could just write down some numbers. So if you did tan of the 80, so if you did tan, come on, so if you had 80 and then tan, or tan and then 80 on on better calculators, you have that number. So 5.767, sorry, 5.67128, and so on. So then you could just do 10 divided by that number, right? Or even here, I could store it as memory and then say 10 divided by memory recall, enter, to make sure the bed mass basically is being carried out properly. Okay, so we got those two. Those are the main uses of it. And then, of course, the third one that I mentioned that we did yesterday, I was thinking we had done yesterday, so I'm pretty sure we did. Yeah, we're looking for this angle that's missing now, right? And so here we'd say the same kind of thing. We're like, well, I know that tan of that unknown angle is equal to the rise over the run. And so if tan equals rise over run, then we just calculate that 4 over 15 as a number. Have to clear this here. 4 divided by 15 as a number. And so we have tan theta equals 2.0299. Like that. And then this is the one where we do tan inverse to get rid of the tan button. We're not really doing anything on this side, but we are on the other side, of course, right? So tan inverse of tan gets rid of tan, and it leaves us with the actual angle, right? So we just have to do tan inverse of that thing. So second function on this one is the little upwards arrow here, and then do tan inverse of that thing. It looks like it gave us 63.8 degrees. Just hang on a sec here. I'm going to pause the video and try to fix the smartboard. All right, I'm back here. Hopefully it's better now. I think there's a mistake here. I think the buttons were not working right here. I'm missing the buttons because of the smartboard here. Yeah, still am too. Oof. It'll be one of those days. So the 4, I'm gonna have to use the mouse instead, I guess. For now, here we go. Clear that, and it's supposed to be 4 divided by 15. I didn't notice that the buttons didn't work properly there. And then just do the arrow and get tan inverse of that. So it's supposed to be 14.93, which of course makes a lot more sense looking at the picture too. So let's fix that up. There it is. So that number really was 4 divided by 15 was 0.266. I'll just do this since it's struggle today with the smartboard. And then tan inverse of that. Boom. Tan inverse of it. And again, you do second tan inverse and then the actual 0.266 and then equals on calculators that are direct algebraic logic, like I showed you yesterday. So 14.94. No, I'm going to copy that just for the heck of it. That's the, that's the answer the calculator gives. And of course, then we say, oh, in other words, about 14.9. And the logic there, of course, is that we didn't know the side length of 4 and 15 to, any greater than a decimal place or two, right? And so it wouldn't make sense to claim that many decimal places. So rounding to 14.9 is equivalent or along the same lines as, wow, the smartboard's even worse now. All right. I will press pause again and try again. Wow. All right, so the answer there was 14.9 degrees or so, depending on how many decimals you keep. It was 14.6 last time because I didn't keep as many or whatever. Yeah. So this is the new lesson. It's not really new. We're just giving names that are more appropriate for all situations rather than just specifically when it looks like this, where we have a nice rise and run. You can see in this triangle here, things are kind of rotated around and you're like, oh, it doesn't really look like a rise and a run anymore, does it? It's like this one's on that angle and that one's on that angle. And so we could like turn this thing around and line it up so that it looks like a rise and a run, but it's unnecessarily confusing. We don't need to do that. We can tackle it in a more generic way. Okay, so instead of thinking those as rise and run, we are going to be looking at we're going to look at the sides as other values that they really are, right? So for example, in this one here, this one's not rise or run. It's really the hypotenuse, right? If you think of the Pythagorean theorem, that's the hypotenuse. And so up here, we'll also look at this angle, like relative to the angle, right? Over here on the opposite side of the triangle, we're going to literally just call that the opposite side. Okay, so it's the opposite side. Normally I just say opposite, but obviously it means opposite side. And then this side right here, right beside it, and so a word that isn't used a whole lot these days in the English language, but adjacent means beside. Okay, so it's the adjacent side. So you think of the opposite side and the adjacent side. And then with this triangle itself, this is the hypotenuse over here, the longest side. So you'll find I'm going to be coaching to label the hypotenuse first. That's a definite side. There's no mistaking hopefully where that one is. You got to start with that so you're on the right track. Then after that, of course, the one that's on the opposite side is really easy. And then the one that's the adjacent is the one that's left over. And the reason why I'm saying that is because you notice the hypotenuse and the adjacent side are both beside the angle, right? But one's the hypotenuse and one's the other side, the adjacent side. So in this triangle here, you can see that this way over here is the opposite side, or OPP for short. This one's obviously the hypotenuse because it's across from that 90 degree, right? And then that would leave this side here as being the adjacent side. So yeah, one of the reasons for doing this, of course, like I said, is that the triangles aren't always lined up looking like a rise and a run, but there are also other ratios of sides that are going to be needed for so that we can solve any right triangle situation where you're missing some information and you want to use your math skills to determine the values. Okay. So in this triangle here, if we're looking for the tangent ratio for the blue angle, then for the tangent here, we'd say, oh, okay, well, that right there is the opposite side. And maybe before we even get started, I might have wanted to, like I said, show that this is the hypotenuse. It's hard for me to remember to do that with tan, though, because we're not using hypotenuse. But at least now, then it's the only other side left is your adjacent. Like I was saying, I like to do. That comes up more naturally when we're doing the other ratios where you're dealing with all of the sides. But so the tangent ratio, we just say, okay, tan of A equals opposite over adjacent. So it's the y over the x in the question, right? So it's based on being the opposite over the adjacent. Okay. And for the red, notice now with the red, the right triangle business is still the same, so that's still your hypotenuse. That didn't change. But what did change here is which side of the triangle is on the opposite side. So now this is your opposite side, leaving this one being your adjacent. Okay, so literally think of it as the opposite side of the triangle, just like if you're standing in a corner of a room, which side's the opposite side? Yeah, so the red here, we'd say, okay, tan of B equals the opposite side, so that's the x, and that's over the adjacent, which is the y. Okay, and again, I'll just make it obvious here that we're saying like that's the opposite side and that's the adjacent side. Okay, so that's the tan ratio. And we're going to put this all together to do all three of the ratios. There's two more, but we'll save that for when we group it all together. So when we do this one here for solving for x, then you could start out by saying, okay, I know this is my hypotenuse. Anchor that in place, and then everything else should be doable, where you'd say, okay, well, this is the opposite over here. This is the adjacent then, the only other side left over. And so basically what you want to do later on, once we're doing all the different ratios, is see that we're working with, the known and the unknown there are the opposite and the adjacent. And this is the angle, relative to that angle. And so basically that's why we're choosing tan, but that comes in a little bit more later on. So tan of the 77 equals the opposite over the adjacent. So it's one of those ones. And so you're going to multiply both sides by x. And have x times tan of 77. Now, while I'm at it here, I might as well it's up to you. We could do that tan of 77 as a number. So tan of 77, or just do it when you're doing the calculations. Either way works. So if we did tan of 77 degrees, boom, do 77, do tan of it. On this calculator, lots of calculators, I'll show you this one. Lots of calculators, more modern calculators, you do tan first. So you hit tan and then 77, and you can see on the screen it's doing tan of 77. And then you press enter. Okay, so 4.33 or so. So I'm going to do 4.33 ... meaning I'm keeping more decimals and keep a reasonable amount at least. So 15 divided by that thing. So again, if I did stored that in memory and then did 15 divided by memory recall here, gives me 3.463. So about 3.5 or 3.46 or something. When I'm rounding in the end, and this calculator here, I've had that number there, and so it's more natural in this one. I can just do 50 divided by, and then hit second and get the answer button down here at the negative beside the enter. So same thing. Oh, that didn't work out, did it? I did times by accident, that's why. So let's do, too late. Never mind. I did multiply instead of divide by accident. That's what happened. So let's move that down and divide by 4.33 to show what we did, of course, right? So you get the value, the 3.46. And I have the answers on this slide. I often leave the page of the answers in case I need to print it out for someone if they're going on vacation or something. Helps out sometimes. So solving for the sides using tan continued here. This is the other version. So this one here, again, label hypotenuse first. And then after that, your opposite side. And the only other side left over is your adjacent. So we anchor those in place, knowing which is which, and we can carry it out. So we can say, okay, we're using tan here. Obviously here because it's a tan lesson, but also in the future because we're working with the opposite and the adjacent, right? And so it's going to be the tan ratio. Tan of 31 equals y over 9. And so this is an easier type where we're just multiplying both sides by 9. And so we have 9 times tan 31. So 31, do tan of it, and then multiply by 9. So 5.4 or so. Here we go. So we get y equals 5.4. So on the ground. Okay, so that, just double check my work there since I don't have a team with me here to check my work. And so the final one where we're looking for the angle, right? So we're looking for that angle, and let's do the normal label of the hypotenuse first. And then label the opposite side. And the other side has to be the adjacent. That's supposed to say adjacent. I'll make it so it looks a little bit more like ADJ. ADJ. And so here we're going to do, so again, opposite and adjacent. So we're using tan. Tan of the unknown angle t equals the opposite, which is the 12, over the adjacent, which is the 7. And so we have one of those ones where we're going to do tan inverse to get rid of that stuff. Get rid of tan, right? Tan inverse on both sides. And so that'll get rid of tan, leaving us with just t, the angle itself. And so tan inverse of the 12 over 7. So if I did 12 divided by 7, I have that. And so I'm going to store that in memory. Just basically, I need to do tan inverse of that number. And so I'm going to say tan inverse, so second, tan inverse. I'm going to clear some stuff here. So I need to put that number in. I store it. 12 divided by 7. That thing. And then I can just do tan inverse of it. Boom. So 59.7. And that's because it's an angle, we're getting in degrees, right? So double check here, 59.7, good to go. Okay, so if we go back to that original opening question, we did it based on thinking of this as rise over run, but now we can do it in terms of opposite and adjacent just as easily, and that'll set us up for tackling the other two ratios. Not having to have them lined up looking like slopes and so on, right? Like right now, obviously it looks like slope because it was set up that way for the question. But if I were to group that stuff together, and if it was written like, like this or something, you have to twist your brain a little bit to try and make it look this way so that there's an obvious rise and run. So what we're doing now is we're saying, oh, that's just your hypotenuse here. So got that one anchored in place. And then we have over here on the opposite side of the triangle is clearly the opposite side. And then the other side is your adjacent, and you carry out the number, right? So now we're going to say the same as before, really. Tan of 38 equals the opposite over the adjacent, right? So that's the opposite side. That's the adjacent side. Whereas when we did the opening question, we said that's the rise and the run, which you can see they're equivalent, of course, right? So we're going to do tan 38. So clear that 38, do tan of that thing. 0.78, 1 dot 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 equals y over 12. And so we just have to multiply both sides by 12. And so we get y equals that number there times 12. And we get 9.4 or so, 9.38 if we wanted to keep more, but 9.4 or 9.38, depending on how confident we were or what level of accuracy there was in the original numbers. That 9.4 number, let's just go back to the opening question we started with and see, hey, that's what we had, right? So just a bit of a different naming going on here. There we go. Where are we? There, right there. Figure what slide we're on. Right, so same deal here. We're going to label the opposite there as the opposite side of the 90 degrees is the hypotenuse. And then we're going to look at the opposite side of the triangle. The other side left over must be the adjacent side. And so we're going to use tan, of course, right now because it's the tan lesson, but soon we'll be doing other ratios, and so you'll look and be like, well, I'm using the 10 of the opposite side and the x we're trying to find of this angle that we're given, right? And so we're going to say the tan ratio because we have opposite and adjacent. So tan of 80 equals 10 over x. This is one of the ones that I did at the beginning of the lesson where you're given this one and you're given this one and you're asked for that one, right? So that's no problem. So we're going to do tan of 80. So clear that, do 80 and do tan of it, 5.67. Yep, double check here, 5.67. Now actually I should say 5.67 ... because it doesn't hurt to keep some extra numbers. Tan over x. And next step here would be to multiply both sides by x. And then we're going to have x times 5.67 with some decimals included there that we're going to divide out. So I'm going to end up with a little less than 2 there, what I'm expecting. I'm going to store that in memory and do 10 divided by that answer. We call 1.76-ish, depending on what we wanted to round to. And that's what I had last time, 1.76 or 1.8 or whatever. And then the last one I'll do on a separate page so it can print easier. This one here, same as usual, we'll label that hypotenuse so we get their opposite and adjacent correct. So opposite side of the triangle obviously over here, the other side left over being the adjacent. And so I've got tan of the angle theta equals the opposite over the adjacent. So let's just point out opposite and adjacent, which is why we used tan, right? And so here we need to get rid of tan, so we have just what the angle is, and so we're going to do tan -1. Gets rid of that, and we just have to do what 4 divided by 15 is, and so on, right? Like we did before. So 4 divided by 15, get the numbers right this time, and then we'll do tan inverse of that. So store that in memory. Actually, I can just do second inverse, 14.9, which I remember being the number as well, 14.9 degrees. Okay, well that should work. I think there's a couple application questions starting in on this one too, that's in the homework sheet. So the trick there is just to, if you weren't, especially if you weren't given the picture, draw a picture. And so I'll show that as well. I don't always include application right away, but I feel it's very doable with this stuff. So determine the height of a tree if the length of the shadow of the tree is 3.5 meters long and the angle of the sun's rays to the ground are 30 degrees. So you'd want to draw a tree, so draw a tree, and then draw a sun's rays going down to the ground. We're told the length of the shadow is 3.5 meters long. And the angle to the ground is given as 30 degrees. Just read the information that's given and put it into a picture form, and then you end up seeing a right triangle, and they're on the height of the tree, right? And so to notice that there's a right triangle there where you have the 30 degrees and the 3.5 and the height you're looking for and so on is very doable, right? So if you bring sometimes it'd be a picture given, and sometimes there isn't. And either way, you can really do the question. So just draw the picture and identify the sides and carry out the same process as normal. Okay, whether it was a picture that was given or whether you had to draw it yourself, it should still be very doable. So I'll go in this one here over right here, noticing that it's a right triangle, and so this is your hypotenuse. Over here on the opposite side, opposite colors this time, but so height here is really our opposite, and adjacent is the leftover side. And so we would just use tan, of course, because we're working with opposite and adjacent, and also because it's a tan lesson. Yeah, tan of 30 equals the height we're looking for over 3.5. And so we just have to multiply 3.5 on both sides. And so 3.5 times tan 30 is going to give us our number. So regular tan, clear this stuff, 30 tan. So tan of 30, and then we have to multiply by 3.5. Because that's the height of the tree being about 2 meters. 2.02 or just 2 meters. If it was approximately 3.5, you know. So 2 meters, good enough. And in application questions, it's always like, therefore the height of the tree is, and so on. Conclude what you've determined, right? All right, so hopefully that works for you. The handout sheet is on the side of the class under the Pythagorean theorem poster with the paperweight sitting on it. And give it a try. If you have any questions, I'll be back in class tomorrow. And message me on Teams if you want to. All right, that's it for now. Thanks for watching. Don't forget to like and subscribe, you know, all those things.